Okay, moving on with part 3. In my study site, I also took a close look at baby coral. I happened to find this group of 50 juvenile colonies growing on a dead table coral, and they all looked just great. I didn't see a single sick or dead colony. So every few months I would shoot some photos. And beginning in 2005, I began noticing a fairly rapid die-off. And by the beginning of 2008, just a few colonies were still surviving. In January 2011, just a single colony is surviving. This one right here. This one died during 2010. So, we're looking at 95% mortality here in Rye Rock. But if you go further west, where the water is obviously cleaner, the situation is different. Here again, we find lots of baby corals growing on a dead table coral. In fact, it's not entirely dead yet. And you can see that it's dominated by Acropora, but there's also 14 Isopora. And here's a close-up showing 2 of the Isopora colonies. And I can't see a single sick or dead juvenile coral here. So big difference from Rye Rock. Now compare this with Arno. Arno is still pristine, unpolluted, and here on this dead table coral you see over a dozen Isopora colonies, all in the pink of health. Big difference from Madro. Now another striking contrast is what you find with diseased corals. On Arno, these are quite rare. I've only documented 3 or 4. And this guy, even though the center of the colony must have been dead for weeks, it remains just barely pigmented with colonizing colonial diatoms. These stalked pennate diatoms will cover the dead tissue. Now these also grow on Madro, but they're very quickly outcompeted by ambitious filamentous algae, greens, reds, browns. And these filamentous algae appear very dark brown and then they turn black. One presumes this is due to increased water nutrient levels. Another sign of nutrient excess, what we call eutrophication, is found in the lagoon. Enormous masses of a cyanobacteria called Lyngbia, also known as mermaid's hair. These cyanobacteria are stimulated by both phosphorus and iron, and as we saw earlier, there's lots of iron in the lagoon, and these are simply smothering the coral. Not a species found on outer islands at all. But perhaps more worrisome is this brownish encrusting algae, which aggressively smothers living coral. Again, not something found on outer islands, but here in Ajaltaki and Woja, it's everywhere. And it does not discriminate. It overgrows any coral it encounters. Another algae found, as far as I can tell, only on Madro, is something I call black slime. Now this is actually a red algae. It appears red under the microscope. It's non-calcifying, and it only grows on dead coral or dead bedrock. And it's found only in the most polluted part of the atoll. It's spreading rapidly towards the west. In 2008, it reached the airport, and it's probably past the airport by now. Now what does this do? It decreases the available space for recruiting larval coral. These microscopic larvae sniff their way to their home. They look for the beautiful pink coralline algae. They taste it as they swim over the surface, and they will not recruit. They will not attach to this black slime. The fish won't eat it. The fish find themselves with less turf algae to graze upon. So this black slime is bad news, and it's spreading. It appeared in my study site roughly 2005. Here in 2008, you can see that it is increasing its area by over 10% a year. There are also diseases which are killing the good coralline red algae. This is a transparent bacteria creeping over the algae and killing it. We also have the orange bacterial disease known as clod, or coralline lethal orange disease, which began appearing throughout the Pacific a few decades ago. In the Marshall Islands, it appears to be limited to Madro. And as you can see, it spreads about 2 millimeters each day. The lesions created by this bacteria can be quite large, half a meter across, and they spread every day. Typically, infections are rather small, but there are many hundreds and thousands of these lesions on Madro. Right behind the college, CMI, we find these strange crop circle-like patterns growing down within the dark grooves. So apparently these bacteria don't need to be orange, they're not exposed to ultraviolet light. And then there is an orange bacteria. I don't know how it's related to the other clod, but this orange bacteria moves in a discrete pattern, taking footsteps, as it were, spending 2 or 3 days feeding and then migrating one step forward. Here you can see the behavior over 27 days. The coralline algae is able to grow back, resheet, and erase the footprints. But sometimes you get so many mats, they can eat an awful lot of coralline algae. So now I want to get to the crux of this presentation. What is happening to the brain corals? I consider these to be sentinels. They're long-lived. They're records of past environmental conditions. If you go to an outer island like Rongelat, the brain corals are simply beautiful. Nearly free of blemishes, a few wormholes. The big ones are very old, and they accumulate the burrows of Alpheid pistol shrimp, but they are entirely free of disease. Here on Madro, on the north side, with very little pollution, the the brain corals look very healthy. Here's another North Shore shot. Over on Arno, I was amazed to find an enormous colony of the most uncommon of the brain corals. This is called Leptoria. As you can see, almost 6 feet high. This is the size of a small car. And what's more amazing, just about 10 or 20 meters away, there's another colony equally large. What are the chances? No place else in the Marshall Islands have I ever seen such giant brain corals. And these are very healthy corals. I traced the pattern to create this computer illustration. Notice how big this colony is, maybe 2 colonies joined together, compared to the typical brain coral at its base. Now there are just 2 colonies that I found on Madro of Leptoria, and sadly one of them is infected with at least 6 or 7 lesions, and these infections are spreading. Back to Arno, again, the more ordinary brain corals, are very healthy. I made this panorama on the day that the striatus surgeonfish were recruiting to the reef. There are millions and millions of them. On Arno, you find these hydnophoras, perfectly healthy, unblemished. But back on Madro, surprise, we find disease. Now, I first saw this in 2004 and kept my eyes out, but didn't find any other infections. Notice the green algae marks the area killed by disease. But then I began paying attention to the Agiltaki region, shown in that earlier aerial photograph. And this coral was just part of a routine photomosaic I set up as a permanent transect. When I came back over a year later, I realized we're dealing with a serious infection. Each year that passed, the infection spread from at least a dozen centers. And it'll clearly die sometime in 2011, taking over 5 years to die. I realized that there were thousands of infected colonies, representing the majority of all the brain corals left in Agiltaki. And these slow-growing colonies simply do not recruit very well. I can't find many small colonies. Here's another one. 2 or 3 lesions spreading over the space of a year or two. Another hydnophora, multiple lesions spreading. This green algae is actually the exception, not the rule. This platygyra has no obvious algae at all growing on its lesions, simply a spreading bacteria killing tissue in the space of just 1 year. This is Scapophilia, relatively uncommon coral. Increasing number of lesions, all spreading. Back to Platygyra with multiple lesions. I've overlapped these images to the millimeter. Another Platygyra showing extensive loss of tissue, sometimes with a bit of green algae, sometimes without. This is Symphilia. The arrow shows tissue that is lost by disease, and Favia. Now in Favia, you can see the appearance of 2 or 3 new lesions, which happen to occur at the site of invertebrate burrows or trenches. This hydnophora has no apparent disease, but clearly algae is spreading, destroying tissue. Now here we have another case of algae spreading, but focus on the spot just to the right of this. You find areas of bleaching, which can be moving and temporary. I'm particularly concerned about Pavona. Pavona is often dominant. It forms the foundation of reefs, and most of Pavona is diseased and dying here on Madro, covered with green and red filamentous algae. This Pavona has both algae growing and disease. So the algae is indicated by the arrows. One of several infections is indicated by the ellipse. And this will be dead within a year or two. So we're losing Pavona, and I think this is truly to be regretted. When you look closely at Pavona, they have some of the most beautifully decorative patterns